All right, we should get started now. So, welcome everyone. Can you guys hear me okay? Do you guys see my screen? I'm gonna reshare it though. I'm gonna share my entire screen. So welcome, thank you for joining. We know that there are more people coming, but I just need to get started so we can get into the nice things really quickly. So the idea of today is give a more advanced idea of APIs with Flask. I don't know if you guys have already seen our Flask tutorial. It's a set of video courses we have, but what we have found out is that people are usually looking for more advanced things or things that they can use in real websites. We have tried as much as possible to get to do things that you guys can just borrow and implement your own stuff. We don't like when there is something explained that doesn't have a real live usage, you know. So we want to make something real that you guys can just borrow and tweak it and use it in your own applications, all right, at least to get started. So that's the idea of our Flask tutorial, and that's the idea of today's class too. Because if we, so something that usually happens is that we have explained, for example, how to do simple API authentication, but it is not something that happens in real life. So we want to show you exactly that. The idea of today, and now I'm going to share my screen so you guys can see it, is to do some live coding together. This is the Flask tutorial that I was showing you, telling you, sorry, about a few seconds ago. And again, the idea of today is to explore a set of different options we have for authentication using using authentication in Flask APIs. We are using Flask because we like Flask, right? It's the tutorials about Flask. We also use Flask in our courses. But these concepts you guys can use these same concepts in any other web framework. You can go to Django, to Rails, to whatever framework you guys want, the concepts will apply. And as everything we do, we want to focus on concepts, because if we should show you something specific for Flask, I mean, that kind of falls short. So we want to give you the whole picture, we want to give you the examples, and we want to give you transfer the concepts so you guys can just borrow that and apply it, or at least know about it. You know, it's like you will not go like crazy to create an authenticated API right now, but at least you will know it. And we are talking about advanced and important concepts in this particular class today. So let's get started. You guys can follow, I think Josh was asking, you guys can follow the entire code in this repo. It's still work in progress. I have to fix the README. It's the bare minimums, but it's working, and we're going to use that code, so don't worry. So let's get started with the basics, right? The basic of any type of authentication or authorization is going to be like to follow the ABC of any secure application, and the simplest thing we can do, and that adds a lot of, like, it's 95% of your authentication can be achieved with a good usage of HTTPS, and not just like, hey, have HTTPS, but also checking that you are using the correct ciphers, that you are using the correct TLS version, that you have updated OpenSSH in your server to the latest version. So these, it's like we have to be cautious and provide that extra layer of work. You know, it's like security can be done in two different ways. You can be super fancy speaking about algorithms all time, or you can just do things right. You know, update OpenSSH constantly. You know, getting, I don't know, putting in a calendar to notify you every first of the month to go check a new OpenSSH version. You know, as simple as that. Checking the ciphers. Remember about renewing your domains with enough time. Sorry, your certificates with enough time. So these simple things that kind of scratch the operative board of everyday tasks, those are the most important you can do. All right, so we're going to talk about good authentication practices and mechanisms, but I just wanted to clarify this before we even get started. So maybe the most important concepts we have to talk about is the first one is or the difference between authentication and authorization. It's not written in books, it's just a way I have to see, and I found that it's a standard. And the difference between authenticating and authorizing. So authentication basically says a request is coming into our API, and we can authenticate that, and we can say, this request, I know who is sending this request, and this request is legit, and that involves many things, from I know who the client that created this request is, up to this request was created 3 minutes ago. I have a window of freshness of 5 minutes. This request is valid. That is good. So that's the first question that you have to ask. Can I authenticate this request? If you, of course, can't authenticate the request, that is it. You just return you return an error status code, and that is it. If you can authenticate the user, then the next step is check the authorization. I know who you are. I know you are a legitimate user of my application, but you are trying to, for example, delete this record. Are you authorized to do that? So that's a different deal. It's in similar terms. It's like, I am sending a request, a valid authenticated request with my credentials, but I want to delete some other guy's tweets. For example, I'm talking about Twitter. So I send a delete request to delete a tweet who belongs to other users. So is that valid? The API can authenticate me, and the API knows who am I, but can I do that? I am not authorized to do that. So it's going to return the error code to me. So these are maybe the two most important concepts we have to talk about today. And we will have different mechanisms to achieve any of these. Closer to authentication, we're going to talk about basic auth right now. We're going to talk about a custom authentication method that it's widely used. And we will also talk about SHAWT, JSON Web Tokens. Then the authorization part is a little bit more complicated, because it deals with both having the concept of a user logged in, right? And also with a set of permissions. And of course, that's something that we will not be talking about today. It's like more of a permission thing than anything else. And there is no framework, there is not much to do about that, except that just writing good code and a good test. The delete method in our Twitter API. What happens if this user X tries to delete a tweet that belongs to the user Y? Will he or she be available? And of course, that is just good testing and doing just good, robust software development. So the first thing we're going to do today is I will take the basic auth part just to take the chance to show you the code. Can you guys please see my code? And for you guys to follow how this project basically works. So the project is structured again as a set of steps, as all the other projects we do. We have a simple, maybe the simplest step is the first one, right? We're just using basic auth, and I'm gonna run this application. I'm just showing you how to run the application. The run app is getting the application right from the module, and I am then just spinning the Flask development web server from there. You guys, if you don't understand anything about this or something from this, please go to the tutorial where we explain like step by step what is doing each of these things. It's like, why do we have this app.run, etc. All right, so the first example, we have just one simple route that it's for in our basic Flask sense, it's just an open route. And what we're doing is we're just checking the authorization parameter from the Flask request. All right, and this is built into Flask, the basic HTTP authorization. It's something that it's available pretty much in every web framework. So that's why you guys will see that it's going to be supported by all the frameworks, Flask, Django, all of them are going to support the basic HTTP authentication. What I want to show you is just an example of how to use it. So I have a few requests prepared here. And what I'm doing is I am authorizing, basic auth, and I am sending a request with admin and secret as the username and password. That translates, of course, in an authorization header. This is the basic of HTTP auth. And when I send my request, you guys will see that it's processing correctly and it's returning. I'm just returning these placeholder texts for you guys to see that I have access to username and password. All right. I could, of course, right here write a login method to check if this user actually exists and the password is the one that has passed. I will do something differently in our third example. So I didn't do it right here to leave it as clean as possible for you guys to get familiarized with the project. All right. So that's the very basics. That's the basic auth that it's supported by HTTP, and we didn't have to write any code. Flask out of the box includes the support for this authentication. We just did request.authorization. We got the credentials, and that was it. So now let's talk about a custom authentication mechanism. It is custom because there is no standard written. It's like there is no an RFC for this. There is no, I don't know, there is no standard or protocol for this. It's just a widely used form of authentication that I have here an example that it's the same one that AWS uses. I have personally used this for production apps in many different ways, and it works pretty well. I want to explain you basically how it works and the advantages and disadvantages of these. The first one is that the concept right here is that we don't want to, and this is really important, we don't want to authenticate a given end user. Or let me change it. We are going to have 3 actors involved in this authentication process. The first one, of course, is our API. The final resource. We are building Twitter, we're building Twitter, and we're building the API of Twitter. The second actor is the end user, the guy that created the account in your Twitter service, the one that writes the tweets, deletes the tweets, the one that owns the data. The third actor sits in between these two and is the mobile client, for example, the mobile application, or it's a third-party developer that it's using our service. So, for example, you guys have, I don't know, a service you can just log in and you authenticate with Twitter, and it gives you stats about your Twitter profile. How many followers you have, how many followers you have lost or won, stuff. So what we have there, we have 3 actors. We have our service, our API, we have the end user, and in between, we have some agent that it's using the API on behalf of that user, right? The easiest thing to think about is probably a mobile application, right? We want to authenticate a mobile application, so the requests are made from this mobile application, and we are sure about that. All right, so it's as simple as that. So we are going to have the concept of public and secret keys. When you guys create, for example, an application to develop for Twitter, you're going to get a pair of public and secret keys. You will know those public and secret keys, of course, and Twitter will also know those public and secret keys. And the reason for that is that we're going to use our secret key to sign requests, right? Packages, demands, claims in our like with our own signature, and Twitter will be able to verify it. So the only two actors or agents that have those public and secret keys are myself, of course, and Twitter. We are the only ones that know about those keys. This method is based on HMAC, and HMAC itself is using different algorithms, cryptography algorithms. We usually choose SHA-256. It's a robust one. From now on, I will just leave this as a default. And again, as what we're saying, it's widely used. It's not a standard, but it's used pretty much everywhere. In this case, see, these guys are using SHA-1 for this, but I believe they actually use 256 somewhere else. Anyway, that's how it works. So let me show you how this process is going to work conceptually, and then we're going to go to the code. So suppose that I want to create a request in behalf of another user to post something to my API. I'm following the examples of our first Flask tutorial, so that's why I have /book right there. So the concept first is I want to make a request to create a book. That's my intention. For that request to succeed, I will have to pass two custom headers. Here, I need to make a small note. Usually, we use just one header of the authorization, the official one from HTTP, and we put everything together. I kept it separately for you guys to see it, but it's the same. You can use this if you want. There is no issues with that. I was just for you guys to know it, you know. So we're going to send two headers. And those headers will have a set of credentials that will kind of contain who that client is, and also a signature that will finally verify that. All right, so we're going to add those two custom headers. We're going to send the request. The server will validate that, and if that checks, the server, of course, will fulfill our request. I'm going to show you in detail how this works. So the first one to talk about is the credentials. Sorry. So the credentials is just plain text. Is going to have your public key, a timestamp, and here just to make it more real, I am adding the algorithm, because we might at some point in our API we might want to upgrade the version of the algorithm that we're using, and if we don't clearly specify which algorithm we're using, it's going to be really hard to migrate all the clients. All right, so just for that reason, as I said before, I'm going to obviate this part, but I want you guys to know that it's there. So these are the two most important things. The client is going to say, this is plain text, it's going to send its public key and saying, hey, I am this guy, I am mobile, right? I am the mobile application, and I'm sending you this request with this timestamp. You know, just I am claiming, this is my claim, you know, or the mobile application claim. It's saying, I'm sending this request, I am the mobile guy, public key, I'm showing you my public key, and I am sending this request at this date timestamp, you know? Just one note, parenthesis, we're going to have some period where requests are going to be good, you know. So after 5 minutes, a request is going to be invalid, and I'm going to tell you why in a second. So again, the client is sending its claim saying, I am the mobile client, and this is the timestamp when I'm sending this request. The server will take that, all right, and it will not trust the client. Of course, it will not. We can't trust the clients. We are not going to say, oh, you're the mobile client, all right, I will just fulfill your request. It's going to say, okay, I get it, you are mobile, and this is the time that you have signed this request. What I'm going to do now is verify that. And to verify that, I am going to use the signature. The signature will answer if your claim is true. So let's go really quickly to the signature. The signature has this form. It's going to first sign a string that we're going to build similarly to the one with the credentials, but the string here will have the method, right? We want to make, for example, in this case, it's going to be a post to /books. So we're going to use method post to the path /books right here, and with the timestamp that I said that I was sending. I'm going to bundle all that, creating this string. I am going to sign it then with HMAC with my secret key. And I'm going to send it along with the claim with the credentials. So those two things I am sending to the server. The server has my secret key. So the server will be able to replicate this method, to just replicate this, build the same script. I mean, the server has the method that I'm trying to perform, it has the path that I'm trying to perform the method on, and it also has the timestamp because I told the timestamp in the credentials. So it's going to get my secret key and this timestamp. It's going to build a signature and it's going to compare it with the one that the client sent. So if the client, for example, didn't try to brute force the secret key, it's never going to match. You know, the client's going to say something like, hey, I am mobile, this is the timestamp, this is the algorithm, I want to perform something, it's going to send the signature. And you're going to say, all right, that's your claim, you say you're mobile, and then you send the request at this time. I'm going to check that. And the server has all the means to build a signature that should be exactly the same one as the one the client provided. And to provide a signature, you need the secret key. The only agents, actors able to create a signature are the ones that have the public and the secret key together. All right, so that's how it works. This is a simple schema for you guys to follow, right? This is how it works. The client again sends the request, and it claims like the request, the credentials saying I am mobile, blah blah, and the signature. The server can go to the database and say, hey, give me the key pair, public key, secret key from the guy that says to be mobile. You know, someone is saying that is mobile, so give me those keys. Of course, if the keys don't exist, I mean, if there is no public key mobile, it's just going to respond right there. It's like, this thing doesn't exist in my server. Supposing that it does exist, it's going to get that secret key. It's going to try to replicate the signature. And if the signatures don't match, of course, it's an error. It's just going to give you unauthorized. All right, so that's basically how it works. We're going to see it really quickly in code. So 1 second. We're going to move now to our second example, custom authentication. And the server is being reloaded. There you go. And where is it? No, custom auth. So the application that we have built for this particular case is super simple. There are 2/3 views. There are actually 3 views, but there are 2 views that we are going to pay a lot of attention. The first one is an a view that it's not protected, you know, so anyone can just access /book. It's public, it's just there. So I will try to make that request and I get a 200 OK that basically works. Now, the other two views that I care about are these two that have the custom auth required decorator. It's a custom decorator. I have coded it. It's just right here. You guys we're going to walk this code line by line. These are the methods, sorry, the views, the paths, the requests that we care about. All right. If I make a post request right here, and I am passing here credentials and a signature, it should, there you go, fail because this expired. So how do we build the credentials and how we check them? So the first step that we're going to do is build the credentials, supposing that we are the client. All right, so I want to make a request from Postman, right? So I want to build a set of valid credentials and signatures. Let me show you first our credentials. We have some generated data right here. I have two pairs of keys, a public key mobile app and a secret key secret, and the same thing with smartwatch as a public key. So both the server and me, we both know our public keys, you know? So the two important actors here, they both know the public and secret keys. Now, second step, generate the credentials, which is simple. It's just the public key, the timestamp, sorry, right there, and the algorithm, that is simple, and then create a signature with that public and secret key. To do that, I have just some code here that will take care of that. And it's this sign method. This sign method will take the timestamp. If I don't pass any timestamp, I will of course just get UTC now. It's important to the timestamp to be in UTC to like put it really explicit, be really clear with all your clients. Always send timestamp in UTC. It's really important. And then I have two things. First one, again, credentials, simple, public key, timestamp, algorithm. That is it. Then I'm going to build a signature string, and it's going to be, if I show you guys again the slides, it's going to be this string. So it's going to be method, path, and the timestamp. And then I'm going to get that signature string, and I'm going to hash it using HMAC with the correct algorithm. These two libraries, HMAC and hashleaf, are both part of the Python standard library. So there is nothing to do there. All right, super simple. Just hash the string that you want to assign with your secret key. And of course, then just return the signature and the credentials. So I'm going to show you really quickly how this works. We have a script here, generate signature, that is going to take, there we go. I guess this is pretty small for you guys, but here's, we invoke it just with generate signature, the public key, the secret key, the method, and the path that I want to access. So again, when I want to access right here is post to /book. So what I'm going to do is generate the signatures. I get here a set of credentials. Again, this is simple. It's just public key, timestamp, and the algorithm that I have just created. And I am going to use now my signature in the X signature header. And now I'm going to create the post request, send it, and now I have a 200 OK authenticator. Let's say that I don't have a correct signature. So I don't have that. I'm going to just put something, I know the signature. And I will try to pass this signature now. I will pass also the correct credentials because of the timestamp. and it says 401 unauthorized because the signatures didn't check. Anyone has any question, please just let me know. The important part here is that the server and the client, they both have access to this secret key, and that is a really powerful tool because, for example, I am always including the timestamp. What the timestamp is going to do is it's going to change the secret key every, I don't know, 5 minutes, you know, or it will be required to do that. There is a way to break this authentication system. Let's say that I want to send a request to a given server, and someone in between, a man in the middle, can get my signature. That person, that man in the middle, can replicate the same requests with the same signature, but the window that the attacker has to do that is just 5 minutes because the signature will expire. So these things are the ones that are important. Then, for example, AWS has a more robust system. The signature string is not just the method and the path. It's also, they also encode headers, parameters. I don't know if they encode body. So it is more robust. You know, if you can put more things in there, you're creating more entropy, and your authentication ends up being more robust. All right, so let's see. I don't know if you guys understood how we created the signatures, but I think it's relatively simple. We just need to, just a quick reminder, build this string and then hash everything with the secret key. So now let's see really quickly how the server is going to react. That, of course, is what you guys are interested in. In this case, what we're going to do is, the first thing is we're going to get the headers, and of course we're going to check if both headers are available or they were passed. If they're forgetting any header, we will just return a 401. We're going to get the signature and the credentials, and then we will, of course, try to unpack, right, destruct the parts from this credential. Remember that the credential was the public key, timestamp, and algorithm. If this fails, we will just give them an error. The next thing we're going to do is find the client secret. What we're going to do is go to the database, find client secret. It's right here. It's a database call. We're going to go to the database, and we're going to say something like, hey, I have this guy, public key, that it's trying to access our resources. Do we have someone with this public key? And if the server, of course, the database server doesn't find a public key, that public key, we're going to just abort and give them a 401. If we do find the secret key for that public key, then what we're going to do is, we're going to parse the data or the datetime, right? So the requests are going to be valid just for this period of time. If the period of time, oh no, sorry, 2 steps. First, we're going to parse the timestamp. The timestamp might have a wrong format. And if the format is correct, we're going to check if it's not that old. So is timestamp fresh? It's this one that we have right here. I'm using a max timestamp delta in minutes, that one. And then what I'm gonna do is, if I have reached this point, everything looks good. I do have a public secret key pair with this public key. The timestamp looks good, is fresh. Now I want to verify these claims. You say you are this client, I want to double check that. So what I'm going to do is just sign the same request. I'm going to sign with the public key, with the secret key that I got from the database, the method you're trying to do, the request that you're trying to access, and the timestamp that you have passed. If then the signatures don't check, I will just return a 401. If they do check, I just move forward with the request. What I'm gonna do, just for you guys to know, not necessary, I will store the public key in the SHE object. So then I don't know, any view can have access to that and can know who is creating or who's making these requests right here. Make sense? I want you guys to take a look later at the tests if you want. These are built really well, really carefully put. These are all the tests we have, and they work really well. We have all the cases, right? So we have the one that doesn't require authentication, and for those that do require authentication, we have every case. Like this is the good case, and then we have, you know, wrong headers, not enough headers, wrong signature, wrong timestamp, only formatted timestamp. We have everything tested for you guys to check. All right, if you guys are okay, don't have any other questions, I'm gonna go now with the CHEWT example. CHEWT stands for JSON Web Tokens. And they will sit in probably another space. What we were doing with the custom authentication we were seeing before is we were authenticating claims from clients that were trying to use our API. So again, I want to give you a good example. You guys are, for example, you guys are medium.com, the blogging platform. They integrate with Twitter. So they are a client of the Twitter API, Medium. But Medium will interact with Twitter on behalf of me, right? So these are the three actors involved. Medium will have a set of public and secret keys. Twitter will have the same set of public and secret keys, and that's what we have just seen, how they work together. You know, the actor that was left aside in our previous example, in the custom auth, was the final actor, which is the user. You know, if we have it, there are applications or APIs that don't have the concept of a user. So if we do have a user, in the previous model that was left aside, it's not really hard to add it, to be honest, but it was left aside. So that's why we're going to use now the CHEWT authentication mechanism. It's not intended to validate. It's not intended to validate clients, but it's intended to validate end users. It can be done. It can be used with anything, but mostly, and our example here is going to be focused on that. CHEWT, it's a cool standard. It's a robust standard. It's battle tested, so you guys can check it and use it with no much issues. So how is the CHEWT standard composed? It's going to be, at the end of the day, what we're going to get is just one huge encoded string. And that string will have a header, a payload with data, and a verified signature in the same way that we were doing with custom auth. We are going to say then that we're sending this claim. We claim that this data is legit. We claim that these headers are legit, and we want to do this in your API. CHEWT then will use these claims, and it will sign these again claims, and it will create a final token. So then the authenticated users can use that token again and again and again. What is going to be different from our custom auth here is that the client will never have a secret key. The client will send a set of credentials to authenticate and say, hey, I want to log in your application, and we are going to generate these token, this secret token, this signature. Then the user will, every time that she or he uses our application, will send that token along, and that will be their authentication mechanism. They're going to say, I want to do this, and they will send the token, the secret, the access token that we have given to them. So let me show you really quickly with the code example, because it will make more sense. So what we have right here is we have a simple application we have built using a really good CHEWT client, or library, which is just CHEWT. You guys, if you go to the requirements, you will see it, PyCHEWT. And the way it works is super simple. The first thing we have to keep, it's really important as usual, is the secret key. We, the server, are the only ones having a key. The client doesn't need a key. We're going to provide a method that, of course, the user is not authenticated to, right? If you guys, probably the only endpoint we don't have authentication for is login, because of course the user is trying to log into that in that point. Sorry. So what is going to happen is that the user will send the credentials to log in to this server, and it's going to send username and password. If we do find a user in our database, a user with that username and password, I'm just storing the password in plain text here, so of course be careful with that. But if we do find a client with username and password, what we're going to do is create a CHEWT token, a JSON web token, a CHEWT would be, and we are going to pass that token back to the user. The user is authenticated, it got a 200 OK with the token. For every new request, we'll have to pass that token. So let me show you really quickly how this works. Don't save. So CHEWT. We're trying to post first. Send. Oh, sorry, I had my token. It shouldn't be there. There we go. So I'm sending authorization header not provided. Sorry, so I'm not authorizing to do this request. So what I'm gonna do now is log in, right? So I'm gonna send my body, I'm gonna pass admin and secret. If you guys go back again to this data, we have one user created with admin and secret as username and password. Remember, I'm storing the text passwords in plain text, not the best thing to do, but it's just for the sake of these. And I'm gonna pass this to log in as my user. Of course, if I don't know, let me say to these, if I send it, I get invalid credentials, right? I'm gonna put it again, send it again. There you go. So I have just sent a login successful with username and password, and what I got back was this token. I better keep this token safe. If you guys then what you want to make a second request to, for example, oh, there you go, host. If I want to post and I don't have the right privileges, what I want to do then is just send the correct authorization header. So what I have to do is put authorization with the bearer keyword and a space. This is required. And the next thing that I'm going to do is just send the request. And as you guys see, this works. Now, this request right here, where is it? CHEWT one. When these requests succeeds, it's just giving me the greetings to my username that it has there. So how does it work? Really simple. The first thing we have to understand is, again, we authenticated and we received a signature. That's the most important thing. We authenticated, we received the signature. What we're going to do next is send this signature for every request. And what this thing is doing, I'm going to show you right here, is decoding that given token with our secret. So I'm going to show you that actually in code. This is my token, the same that I'm sending with each new request. And what I'm going to do is just CHEWT.decode with my token and with the secret that I have stored right here. In this case, the secret is this one. And that the code process will give me the data that I had encoded before right here. The username is admin. So what I can do next when I have this CHEWT auth required decorator passing is decoding the token. It's validating it. This is probably obscure. It's like we don't see what's going on, but I'm going to show you a bad example in a second. And if this thing passes, it means that the user is authenticated. And what I'm going to do is just set the current username in my global object so every other user can just then access it. Yep, so the CHEWT standard will use the secret key to generate the token. The good thing here in this protocol is that the secret key is just stored in the server. There is no one else knows the secret. And in this case, there is no step to go look to the database for a user. You know, we never went to the database to look for this user. If this signature and this token is valid, I am sure that this is the user that I authenticated. So I will then trust it because I have signed it, and I don't have to go to the database to look it up. You know, for example, in a cookie-based authentication method, what the user is sending a cookie. So that cookie identifies your session ID. That's what we call it. We have a session ID. And with that session ID, we go to the database, we extract the data from the session ID, and then we have the user we want. In this case, we're saving that one step. We just get the token, we decode it right here, we decode the token, and we get the username. And let's say, so the way we created the token was by encoding the username, right, with our secret key. So let's say that I create, let me encode. I'm gonna encode the same thing, username, admin, same thing. I'm gonna encode it, but now I'm gonna use, let's say that I'm guessing I wanna attack this server. So I wanna guess this secret, but it's not correct, the correct one. Did I encode? CHEWT encode. Oh, sorry, my bad. There you go. So I have just encoded it. Well, let's say it's wrong token. I'm gonna so this is the token, and I'm going to perform here a request to the client, to the server, sorry, saying that I am now this spoofed user. And I'm gonna say now send, and I get a 401 unauthorized. So I know who the user is. I know Josh, so I wanna I don't know, attack the service for this user for SHAWT. So I was just create this claim. I say I am SHAWT, but I don't have the correct key to generate that valid token, you know? So the server will realize that it was just a big lie, because the only valid tokens are generated by the server. Of course, if I do have the secret, if the server ever gets compromised, its secret, then it's going to be a really bad time, because everyone will be able to just duplicate and replicate the tokens. So that is basically how it is. Important here is to understand it conceptually, and I know it's confusing, to understand that there is an authentication process that it's followed by clients, and it's followed by, like, to authenticate clients, for example, a mobile application, someone using the API. And then there is a different authentication mechanism used to authenticate a user, right? 3 actors, the user. So in a complete scenario, we have the Twitter API, we have the mobile client, right? I have a mobile phone, I have the mobile client, and I have the end user, myself. So I wanna create a tweet. I will send this request, and Twitter will first check if the, let's say, custom authentication, that's the first pass, to say, hey, this guy Santiago is trying to log in through this application. Does this application has privileges to work with his data or with data on his behalf? So if someone is trying to spoof my credentials and they don't have an authorized application, that's going to, of course, fail. Now, if that passes, the mobile client is legit, it's using the API as it should. So what it's going to do then, it's going to check my credentials. It's saying like, hey, this is my username, my password, and I'm trying to delete my profile, my entire profile. And what it's going to do is it's going to check if these tokens are valid, and if everything succeeds, then it's going to just go along with the request. Of course, we have these 2 steps, right? Authenticating the client or the actor, and then authorizing the user to do something or not. Make sense? Anyone has any question? You guys have all the code here just to use it. It's a pretty comprehensive way to see it. There are here a couple of important things to note. There are libraries in charge of CHEWT with Flask, right? There is no way to reinvent the wheel. I'm just doing it for you guys to understand how it works. I am also just having like the stupidest database ever, just putting strings, like plain strings right here or here in the password, for example. It's not safe, but I just, again, I want to keep it simple. And again, just check the code, check the tests. These tests are built for you guys to follow them and understand what we're trying to do. So they are going to just help you a lot. Which version should I watch first? Understand the authentication process. Florent, the authentication, you mean like username, password? Simple. If that is the case, you can just check the tutorial. And there are many, and that is that's a good comment, because there are actually also, we don't need to do these manually, right? There are many Flask login, for example, it's really good. There are many libraries that they are already doing this for us, so we don't have to do that. It's just a way to make it work. All right, so anyone has any question before we wrap it up? We are live streaming on Facebook and YouTube, so the recording should be available. All right, so if you guys need it, they will be there. Okay. So thank you very much for joining. Again, I'm gonna show you just flasktutorial.com. Just go check it out. There is all the information, like the previous steps for this are there, and we are adding more content all the time. So all these video courses for free. There are also assignments and projects for you guys, exercises for you guys to work. So see you. Thank you very much for being part of this quick class. I think we kind of got into a couple of really interesting topics, right? With advanced authentication. So I hope it's helpful for you. And see you all. Thank you, Josh.